Welcome to Simultaneous Equations Level 2. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 6x plus 6y equals minus 6 and 3x minus 2y equals 12. Now, in order to solve these, we need to eliminate one of the variables, which means we need to either get rid of the x's or get rid of the y's. And in order to do this, we need the same number of x's in both equations or the same number of y's. And since we don't have that here, we need to multiply one or possibly both the equations to make this happen. Now, looking at the x's, I could multiply the bottom equation by 2 and I'd have 6x's in both, and that could work. Or looking at the y's, I could multiply the bottom equation by 3 and that will give me a 6y in the first equation and a minus 6y in the second, and I could then eliminate the y's. Now I'm going to choose to make the y's the same, because I know that if their signs are different I'm going to add, and adding tends to be a little bit easier. So I'm going to multiply the bottom equation by 3, and so this gives me 3x times 3, which is 9x, minus 2y times 3 is minus 6y, and 12 times 3 is 36, and the equation above just stays the same, so 6x plus 6y is equal to minus 6. Now, as mentioned earlier, we have a positive 6y and a negative 6y. So to eliminate these, we're going to add the two equations together, because 6 added to minus 6 makes 0. So we're going to add everything together. So 6x plus 9x gives us 15x. The 6y and the minus 6y add to cancel out. And on the right, minus 6 plus 36 is 30. We now need to solve this equation to find the value of x. And we can do this by removing the times 15 in front of the x, by dividing by 15 and doing the same on the right. And on the left, the times 15 and the divide by 15 cancel out to leave us with x. And on the right, 30 divided by 15 is 2. So x equals 2 is the first part of our solution. We now need to substitute this value of x back into one of the original equations to find the value of y. Now we can use either equation, but the top one, 6x plus 6y equals minus 6, looks a little easier because it has a plus in the middle. So if we substitute x for 2, we have 6 times 2 plus 6y is equal to minus 6. 6 times 2 is 12, so we have 12 plus 6y is equal to minus 6. We can now solve by subtracting 12 from the left to remove this positive 12 and do the same on the right. On the left, the plus 12 and the minus 12 cancel out to leave us with 6y, and on the right, minus 6 minus 12 gives us minus 18. We can now remove the times 6 in front of the y by dividing by 6 and doing the same on the right. And on the left, the times 6 and the divide by 6 cancel out to leave us with y. And on the right, minus 18 divided by 6 is minus 3. So y is equal to minus 3. And this means that our final answer to problem 1 is x is equal to 2, y is equal to minus 3. In problem 2, we're solving 4a minus 2b equals 8 and a plus 3b is equal to minus 5. We're going to solve by elimination here, which means that we need to either eliminate the a's or the b's. And this means that we need the same number of one pair in each of the equations. Now at the moment we don't have the same number of a's or the same number of b's. But we can see that if we multiply this bottom equation by 4, this is going to give us a 4a in both equations. So if we multiply the whole equation by 4, we have a times 4, which is 4a, plus 3b times 4, which is 12b, and then minus 5 times 4 is minus 20. And the equation above just stays the same. So 4a minus 2b is equal to 8. Now that we've got the same number of a's in both equations, we notice that both of these are positive. And so to eliminate these and remove them, we need to subtract them from each other, because 4a minus 4a is 0. And this means that we need to subtract everything in this equation. So starting with the a's, 4a minus 4a is 0. Then moving on to the b's, minus 2b minus 12b gives us minus 14b. And on the right, we have to be really careful because we've got 8 minus minus 20. That's 8 minus minus 20. And we need to spot that these two minuses actually make a plus. So this becomes 8 plus 20, which is 28. To find the value of b, we now just need to remove this times minus 14 from the front of the b, and we can do this by dividing by minus 14. And we need to do the same on the right. So on the left, the times minus 14 and the divide by minus 14 cancel out to leave us with b. And on the right, 28 divided by minus 14 is minus 2. because 28 divided by 14 is 2. If we divide it by a negative, it becomes minus 2. So b is equal to minus 2 is the first part of our solution. To find a, we now want to substitute this value of b back into one of the original equations and then solve. And looking at those two original equations, the easier one to solve looks like the bottom one. A plus 3b equals minus 5 because this has a plus in it. If in here we replace the b with minus 2, we have a plus 3 times minus 2 is equal to minus 5. And because 3 times minus 2 is minus 6, we have a minus 6 is equal to minus 5. And to find a, we just have to remove this minus 6 from the left. And we can do this by adding 6 to the left and doing the same on the right. On the left, the minus 6 and the plus 6 cancel out to leave us with a. And on the right, minus 5 plus 6 is 1. So a is equal to 1. And this means that our final answer to problem 2 is that a equals 1, b equals minus 2. In problem 3, we're solving 2e plus f equals 0 and 5e minus 3f equals 22. Now we want to solve by elimination again, and again we either need the number of e's in both equations to be the same, or the number of f's in both equations to be the same in order to eliminate them. Now we can see here that if we multiply that top equation by 3, then we're going to have a plus 3f in the top equation and a minus 3f in the one below, and so we can eliminate them. So if we multiply everything in that first equation by 3, we have 6e plus 3 times f is 3f is equal to 0 times 3 is 0. And the equation below just remains the same. So 5e minus 3f is equal to 22. Now here we're eliminating the f's. And because we have a plus 3f and a minus 3f, to eliminate them, we're going to add them together. Because 3f plus minus 3f is exactly the same as 3f minus 3f. And that becomes 0. So we're going to add everything in both equations together. So starting with the e's, we have 6e plus 5e, which is 11e. We know that the plus 3f minus the minus 3f becomes 0, so it disappears, and 0 plus 22 is 22. We can now solve this equation to find the value of e. And to remove the times 11 from in front of the e, we use its inverse, which is to divide by 11, and do the same on the right. So on the left, the times 11 and the divide by 11 cancel out to leave us with e. And on the right, 22 divided by 11 is 2. So e equals 2 is the first part of our solution. So we now need to substitute this value of e into one of the two equations to find the value of f. And the equation at the top definitely looks easier to use because it has a plus in it. So we have 2e plus f is equal to 0. If we now substitute e for 2, we've got 2 times 2 plus f is equal to 0. And since 2 times 2 is 4, we've got 4 plus f is equal to 0. And so we just now need to remove this positive 4 from the left-hand side. And we can do this by using its inverse, which is minus 4, and doing the same on the right. So on the left, the plus 4 and the minus 4 cancel out to leave us with f. And on the right, 0 minus 4 is minus 4. So f equals minus 4. And this means that our final solution for problem 3 is e equals 2, f equals minus 4.